Alright. So today, we are just going to do a little bit more proof practice. These proofs on this paper are a little bit more challenging than ones we've been looking at. Okay? They're just a little bit more challenging. Okay? Because it seems like we've been doing pretty well with the triangle proof, so I think it's a homework assignment. Yes, I was actually a day ahead with today's assignment yesterday. So we're going to do some of it together, and then some of it's going to be homework. No. So we're going to go through a couple of these together, okay, and then I'm going to have you guys try some. So let's look at this first one. Okay, all we're given is a parallelogram, and then I'm given that AD and BC are parallel. I'll mark that on the diagram, and I'm given that AD and BC are congruent. Okay, so I'll go ahead and start with that in my proof. So AD is parallel to BC, and AD is congruent to BC. Okay, so my ultimate goal is to prove that AB and CD are congruent to each other. Okay, well, I don't have any triangles in here. Like this doesn't even look like anything we've done. But okay, what we can do is draw in a segment. Okay, we can always draw something in. So I'm going to draw in a segment from A to C. Now, why would I be allowed to do that? Well, I mean, that's true. I'm not trying to prove that it's parallel or anything. But why would I be allowed to draw a line between 2 points? There's always a line between 2 points.
You just can't see it.
Right? We talked about that in the first chapter. We've never used that fact in a proof. Right? So, I mean, there's a lot of ways that we can word this, but say there's always a line between 2 points. Okay, so now it looks like a problem that we've worked with. Okay, now what can I use? I can use the reflexive property, and I can use alternate interior angles. Okay? So we could say that these two angles are congruent. So we could say angle BCA is congruent to angle, whoops, I put that in the wrong spot, didn't I? Those two angles. So DAC, and that is because those are alternate interior angles. Then, like Marissa said, we can say the line that we just drew is congruent to itself because of the reflexive property. So we can say AC is congruent to AC. Now what can I do? Now I can say that triangles are congruent, right? I have enough information. I've got side, angle, side in both of these triangles. So now we can claim that triangle, BCA is congruent to triangle DAC. We said that would be side, angle, side. So I've got two sides and the angle in between for both triangles. So now, to finish this proof out, what we talked about yesterday, right? Once I've shown two triangles are congruent, then I can claim any pair of corresponding parts are congruent because corresponding parts of congruent triangles are congruent. Okay? We feel okay with something like that? Okay? So let's do another one together here before I turn you loose. Okay, let's take a look at the second one here. You're not good at that. Alright, so I'm given two pairs of congruent angles. Right? I'm given that angle 1 and angle 2 are congruent, and angle 3 and angle 4 are congruent. So that's pretty nice right off the bat. So angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. Okay, so my ultimate goal is to prove that M is the midpoint of JK. Okay, well, to get there, I'm going to have to prove that these two segments are congruent, right? Segment JM and segment KM. Well, to get there, I'm going to have to show that these triangles are congruent. So what other information do I know for sure from the diagram? Right, they share a side. So I can say OM is congruent to itself by the reflexive property. Reflexive. Reflexive. Okay. So now, what can I do? Yeah, I now have enough information to say the triangles are congruent by angle, angle, side. So we can say triangle OJM, angle, side, side is the one we can't use. No donkeys. So OJM and OKM, and that is angle, angle, side. Okay, so now, we can claim that these two segments are congruent because corresponding parts of congruent triangles are congruent. So I can say JM and KM are congruent. Because CPCTC. Yes, you know CPCTC. Corresponding parts of congruent triangles are congruent.
Cows. A. Crocodiles. 2.
Okay, so now, if I know that these two segments are congruent, how can I claim that M is the midpoint of JK? How can I claim now that M is the midpoint of JK?
It's in the middle. Just say it's in the middle. Up to your thing. So it's two congruent.
Oh, because JM plus JM equals
JK.
yeah.
That's true, but that doesn't necessarily tell us that M is the midpoint.
But they're both congruent. If JM is congruent to MK, and they're both if JM plus MK equals JK, then they have to be in the middle. That's my point.
Yeah, it's just going to be definition of midpoint.
Okay.
Right? Once I've shown that the two halves of the segment are congruent, then I can say, well, that means that M is right in the middle. Okay, that's just what it means to be a midpoint. So on a lot of these proofs, okay, we're gonna have to find like an extra piece of information somewhere, or go one step further, like we did here, than the proofs that we've been looking at. Okay. Questions? All right. So let's see. There's 12 of them on here.